Thank you very much. Hi, everyone. I'm Adam Ernst. I work at Facebook in New York City, and I'm here today to talk about immutability. So, what is an immutable model? What do I mean by that? And why is it a good thing? Why can they help you write better apps, especially if you work with a large team and a large app? Let me give you a little bit of background about myself. From 2009 to 2012, I was an independent app developer. The main app that I made was iTrans, which was an app for the New York City subway. Now on this project, I was a team of one. It was just me. I was the only one that wrote code or read the old code. But around 2012, Facebook called me up. And they said, hey, we're rewriting the app. We'd love to have you be a part of it. Why don't you come and help out? And I said, I can't resist that. Facebook is the most widely used third-party app on iOS. And at Facebook, we started out with a pretty small team of people rewriting that app, but it's grown to where we have well over 100 iOS developers now. So one of the largest iOS teams out there. So for me, it was a big jump going from being all the way on my own to working with a really large team. So I'll come back to that theme in a little bit, but first I want to talk about models. For those of you that are app developers in the audience, you probably have a pretty good idea of this, but what is a model? What do I mean by a model object? A model is just something that holds information. So for example, a person model represents a person, and it might have information like this person has 3 friends. Or a story on Facebook, you have lots of stories in your feed, and it might have some information like this story has been liked by 1 person. So when we're dealing with models in our apps on iOS, what properties do we want out of the system that we use to deal with those models? A pretty obvious one is persistence, right? If we download some data from the Facebook servers, or in your app if the user creates it locally, we want to be able to save that data to disk, and then when the user restarts the app later, read that data back out. That way we can avoid that expensive re-downloading from the server. And another property we might want is consistency, right? So let's say that you're seeing the same Facebook story on 2 different screens of the app. And you like the story on one screen, and then you go back to the other screen. You probably want that story to show up as liked there too, otherwise the user's going to be confused. Did I like the story? Did I not like it? Side note, by the way, back when Facebook was powered by web views and HTML5, this was a nightmare because there were 2 separate web views and had no way of communicating with each other easily. So switching to native code made it a lot easier for us to give you the guarantees of consistency. So when we were deciding to rewrite the Facebook app back in 2012, which actually happened just before I joined when they were making all the big technical decisions, we needed a way to deal with models in our native code. And the first rule of software engineering is don't reinvent the wheel, right? So we decided to go with what was the built-in option for dealing with models on iOS, and that is core data. If you've built iOS apps, you've probably used core data. It's still the first option I would look to if I were building a brand new app on my own today. Core data, Apple describes it as an object graph management framework, meaning that it contains a whole bunch of objects, tracks them all, and then also manages the relationships between them, the graph of objects. It's backed by SQLite underneath the hood, or various other systems that you can use with it too. So at first, core data worked out great for us at Facebook. When we rewrote from HTML5 into native code backed by core data, feed was almost twice as fast. Users saw a lot more stories because they didn't have to wait for that loading spinner with HTML5. And so obviously we wanted to bring that same speed to other parts of the app. So in the next release, we ported timeline to native code. And then the next release, we ported groups to native code. And after that, pages and search. And then we realized, uh-oh, we have a problem. Every single release, as we ported more and more features into core data, the time it took to load your stories and display them in Newsfeed was getting slower. And we weren't modifying Newsfeed at this time, so that was a bad, bad sign. So we did a lot of digging, but it turns out the problem was with the model layer. And the question is, what's the matter with core data? Why didn't it suit our needs at Facebook? And it breaks it down into 3 basic areas. First is setup performance. Core data takes a long time to set up, especially for large, complex apps like Facebook, and particular to the way we were using it. Second, even when we finally got core data started up, core data was too slow at runtime. It would result in blocking the app and making the app stall and really sluggish. And finally, even if core data had been blazing fast, and if it had, we probably would have stuck with it. But even when core data is blazing fast, it sticks us with a programming model that we don't like when we deal with large teams and large apps. And I'll explain why in a little bit. So here's a graph showing kind of the trend that we had for setup performance for our core data at Facebook. It got worse and worse with every release. Even though we were adding a linear number of types in every new release, the number of relationships between all those types would grow quadratically, right? Because if you connect every single type to every other type, that's going to grow really quickly. And the way core data works, every single type in that database, it makes a SQLite table for it. And every relationship, it makes either a SQLite index or another SQLite table. So when we start up the Facebook app, when you press that blue F icon, you'd be stuck there staring at a screen as SQLite issued hundreds and hundreds of create table calls. Not what you want to do when all you want to do is read your newsfeed. Core data also encourages us to have one monolithic object store. That is, if you want consistency between all the different parts of the app, we could have split up core data. We could have said, all right, we're going to have different core data databases for every part of the app, and then they wouldn't all interfere with each other and slow down the overall curve. But then we wouldn't have consistency between those two different screens. So what we really want is a bunch of small, independent object stores, but we do want them to communicate with each other in some automatic way, and core data doesn't make it easy to do that. Second, the runtime performance aspect. We would ideally have something like this. Each part of the app can create and can process and deal with data, and it doesn't block all the other parts. It might asynchronously notify other parts of the app saying, hey, here's some new data that I processed. You might want to do something with it. But it shouldn't block them. Unfortunately, core data has a model more like this. There's only one NS persistent store coordinator. And so anytime any part of the app needs to save data or resolve a fault or load data from disk, it takes that lock. And that means that if newsfeed downloads some data, it's going to block every other part of the app while it's doing that. And so on with other parts of the app. And as you can imagine, the more features you add, the more they're all contending with each other and blocking each other. Core data also has a feature that's really problematic for runtime performance called faulting. So let's say you have a comment in memory here in blue, but we didn't load the author yet. It's still on disk. So if you scroll through your comments on Facebook, you would notice back in the day that it would stall a lot. And the reason is that every time a new comment scrolled into view, we'd be blocking the main thread, going to disk, reading the author's information, and then returning to you. And it turns out disk is really slow, especially on iPhone 4s and older devices. So this was really bad for us. Now, faulting is supposed to be kind of magical, right? You don't notice it's happening. Core data is taking care of it for you behind the scenes. But we thought it would be better to have no magic than magic that we don't understand and is hard to control. Now, finally, the programming model. This one's not really a problem with core data per se, because my objection is broader. The objection is not what's the matter with core data, but what's the matter with mutable models. What do I mean by mutable models? You probably think of most models in the mutable way when you write them in your apps. That is, you have read-write properties, and if you want to change a property, you change it, right? What makes more sense than that? An immutable model would have only read-only properties, including other relationships. So the person's picture would also have an immutable reference to an immutable picture. With mutable models, anything can change anything at any time. This is a big problem for us in the core data app where we'd have unpredictable, different parts of the app that we didn't expect trying to modify objects. Makes it really hard to reason through why something's happening, when it's happening, and what it's going to result in happening in the user interface. Another key thing about really large apps is that two-way bindings are the root of all evil. If you're an iOS developer, you know this as KVO, or key value observing. It's a way to say, hey, when that property changes on that object over there, tell me about it so I can do something. Like you might want to update your user interface to reflect that changed value. So what's wrong with two-way bindings? Well, pop quiz, what does this code do? You might say it increments the number of likes by 1, right? That's when I read that code, that's what it says. But with two-way bindings, it could be doing literally anything because anyone could be registered as an observer to the number of likes property. So We might start by changing the number of likes, but that could result in this humongous cascade of unpredictable actions in our app, all just because we changed the like count. And this results in a lot of cycles, right? You could have one change that triggers another change that triggers another change, and it eventually loops back until it's just a cycle of never-ending changes. Or it can result in race conditions, right? Like you have 2 lines of code, and if you swap them, a bug happens. Swap them back, bug doesn't happen. Like what happened there, right? It's really frustrating to deal with. Models being mutable also means they're thread-defined. In this day and age, we really want to be able to just, dispatch async and do some work on the background thread with that model object, computing, say, let's say we want to pre-compute how the story's text should be rendered on the screen. With core data, you can't just pass that model off to a background thread, because if you read from it, you would end up triggering a thread affinity violation. Instead, you have to grab the managed object ID off the NS managed object, pass that to the background thread, refetch it. It's just a nightmare of complexity and lots of stuff you don't want to deal with. So one of my favorite things about working at Facebook, where we have a lot of resources to deal with, is that we can think big when we have a problem like this. So we stopped and we thought and we said, what would we do if we were starting fresh? Even though we had already committed to core data was all over our code base, what would the ideal end state be? And that is 100% immutable models. So that means if you try to write code like this with an immutable model, you literally can't. The compiler will just tell you there's no setter for this property. You're not allowed to do that. So instead, the first question we got was, well, how do we change things? Like, things aren't the same forever. And the answer is you make copies, and you change those copies privately in a private way that you don't know about. So for example, if we had a story with 0 likes and we wanted to increment that, we would just copy the story, make a brand new model that has likes equals 1. And then we would pass that story into the code at the very top level, and then it would deal with re-rendering that story. So here's what the code looks like now, right? Now you say, all right, hey, consistency manager, I want you to handle this update. Given this story, I want you to set the number of likes to this new value. Here's the update, go. At the end of this function, the story object still has the old number of likes, right? There's going to be a new story object that's going to come through a flow that'll have the new value. So what is this consistency manager? It's this object that sits there. There's just one of them. And basically, different parts of the app interact with it in 2 ways. One is you can give it one of these immutable models and say, hey, if anything changes in this model, if you have a new value for any of these immutable values, give me back a new version of the model with all the new changes. And it does this in an asynchronous API. So it's not guaranteed that you'll receive those updates right away. It computes the new models on a background thread, so it never blocks the main UI thread, but you will eventually get the new values. And the other role it plays is that whenever you download data from the network, you should pass it to the consistency manager and say, hey, here's some new data I loaded. You might want to update other models if you realize that something changed. So if I download a notification in this example, and I notice that one of my friends has a new profile picture, and he also shows up in one of my feed stories in newsfeed, we should go and update that newsfeed story to show the new profile picture so that you are not confused by 2 different profile pictures. This does mean there's no object uniquing. One of the nice features of core data is that if you have three different references to Ari, my friend, they all are the same NS object. They all have the same memory address. Makes sense, right? But this means you need mutability, because you need to be able to change the object, and it means global locking, right? Because if you're going to have only one Ari, you need to take a lock every time somebody tries to get Ari and make sure that you either look up or create an Ari. With immutable models, there can be many different versions of the same person, all different NS objects. They might even have different values, right? Well, they might have different values for that number of likes or number of friends property on it. So a little confusing to get used to it, but once you get used to it, it makes a lot of sense. In our app, there's also no longer a central component responsible for persistence. One of the frustrating things about core data to me is that persistence is all or nothing. You can't say, all right, I want you to persist this object, but not this one, to disk. Which kind of makes sense, right? How would relationships work if you had an object that was on disk pointing to an object that wasn't? But in Facebook, we rarely want to persist data to disk, only a certain small number of things. And core data forced us to save everything to disk, which was terrible for performance. With this immutable models framework, we just use NS coding, which is the built-in, very lightweight system for persistence on iOS that lets you take an object, freeze dry it to disk, and then read it back up again at some later point. We did do one optimization, which is that we made our own subclass of NSCoder called MessagePack which uses MessagePack instead of NSQt Archiver for coding. And it turns out this is way faster, so that was a pretty big win for us. So the number one question we got when trying to roll this out was, how do I know what changed? If I'm writing some UI code and I want to know when a property changes, how am I supposed to do that inside my UI view or whatever? The answer is, don't think in terms of deltas and bindings, right? Don't think like, oh, I want to know when the name property changed on that person. Instead, you should always be getting data from your parent, updating whatever you need to update based on the latest object you've been passed. And then you might want to pass on some models to your children. It's all about parent-child, not deltas and going back and forth in the horizontal way. Secondly, this does mean we have to make the user interface very efficient at doing nothing if nothing has changed. Because every time any value on the story changes, anything anywhere inside that story, you're going to get a brand new story object. And if your story view re-rendered itself every single time anything changed, that'd be pretty bad. So we've got to be a little careful there. Technical details, these models are code generated based on a server schema, so we actually just download from the server a description of what types there are, and then generate the client models. Very, very nice. They're plain old NS objects. Very fast, they're always in memory. There's no magical, let me block the thread for you and go to disk. We don't want that. And we generate it using MoGenerator, which is an open source framework for generating model objects using some custom templates. So we ported Newsfeed to this new architecture, these immutable models, and we're still porting the rest of the app to it today. We're about to finish in the next month or two. What are the results? It was 35% faster to load Newsfeed because we no longer had to deal with core data going to disk and all that. There were far fewer bottlenecks. Different parts of the app no longer trampled on each other, trying to get that persistent store coordinator lock. So we saw a lot less blocking the main thread, a lot less, frustrating app freezes as core data did its work. But finally, and most excitingly, it was a better programming model. On a really large team, being able to reason about the code and the flow of data, no longer having two-way bindings to confuse us, meant the app was a lot more maintainable. We saw a lot fewer surprising things happen. So what about your apps? A lot of you probably work for small to mid-sized companies, not a huge company like Facebook. I wish I could say that there was a really great open source immutable model framework for iOS and go start using it and here's the GitHub link. Unfortunately, there's not. And we haven't open sourced ours because it's pretty tied to Facebook's infrastructure and it's hard to open source. We definitely want to someday, but just not there yet. So if one of you wants to write such a framework and open source it, I would love to see that. Otherwise, it might not make sense to invent your own. It's a lot of work. It was a lot of work for us. Facebook has a lot of resources. So that was great. But it might not make sense for every app. But you can start finding ways to apply immutability on a smaller scale. That means if you look at the properties on your objects, do they all need to be read-write? Maybe some of them don't change. Or if you're writing an app like, say, the New York Times, where you're just downloading server data and displaying it, and nothing ever changes because it's just purely immutable, there you go. You don't need mutability. Facebook definitely things change because people like stories, make new posts, but not all apps are like that. So you may not need core data's mutable features in your app. So I said I was going to talk about immutable models today, and I have, but I have a bonus for you guys. I'm actually going to talk about immutable UI as well, because we sat down and we thought, well, we got all those benefits out of applying immutability to the UI, to the model layer. What if we also did it in the UI? And so the usual way of building UIs on iOS is model view controller, right? You have a controller at the center. Views and models shouldn't talk to each other directly very much. The controller kind of mediates the flow of data between those two. So let's examine if we built Newsfeed in iOS using model view controller, what would it look like? Well, we've got our list of stories here. We've got subviews like story views, and then within those story views, there's going to be things like a like view, right? So we need a controller setup. So let's say we could have one top-level controller for all of Newsfeed, but that would be a really bad design, right? We'd probably have thousands of lines of code in there. So we're going to break it up into a controller for every story inside feed, and then each story controller might have subcontrollers for the like button or things like that. So the feed controller is going to be responsible for managing the feed view. Story controller manages the story view, and so forth. Now we need to flow a model in there, right? We've downloaded some data from the network. So we pass a story model into the feed controller, and it's going to pass it down into the story controller and its subcontrollers. Each of those will update its corresponding view to show whatever data is on that model. All right. So now the user taps a button. They tap the like button. What now? Well, we're going to send an event back to the like controller, which is going to update the model store, and that might change something about the story's height or how it's rendered, so it might need to communicate to its parent controller, hey, my height changed, update the table view, please. So that flows upwards. And of course, that's for the like view, but similar things could happen at the other layers of feed and story. So there you have it, feed and model view controller. And what's the problem here? 16 arrows, that's a lot of arrows. There are a lot of different directions that things can take. And it's really, really hard to understand it all. And this is only a very simplified feed with only nothing but a like button. Imagine what the real feed would look like with all of the complexity that you have. So let me jump right to the solution, and then I'll explain how we got there. We went for a declarative, immutable way of writing newsfeed. This is what it looks like. It's really alien to you if you're an iOS developer, because it uses a lot of Objective C++, which means a lot of crazy curly braces. But the general gist of it is that you declaratively state, when you look at a newsfeed story, I want you to stack things. I want you to stack them vertically, stretch them horizontally so they're all the same width, put 10 points of spacing between each item, and then a story is made up of like a header and a message and a like and comment bar, right? That makes sense. So how did we get there? We start with UIKit on iOS, which has a mutable hierarchical view structure, right? You can add subview, you remove subview. Those are mutable methods. They mutate whatever view is already there on screen and add a new or remove a view on screen. You override a method to calculate the view's size or lay out its subviews. And all this means with mutability, you have thread affinity, right? You can only use views on the main thread. And that kind of stinks because if we download 100 new stories for you, we don't want to block the UI thread and slow down everything while we compute, all right, how tall are all those stories so we can give the right height for row at index path. So we really don't like mutability. We learned that in the model section of the talk, right? It results in a lot of confusion, and it also means we're stuck on the main thread. So our goals were, we want to make it easy to lay out and recycle views because table view cell recycling is really important for performance. We want one-way data flow. We don't want all those arrows flying every which way. We want it to be, really easy to reason about how data flows through the system. We want to encourage composition. If I had one piece of advice, it's avoid subclassing at all costs. It makes it so hard to reason about the code. And we want to enable asynchronous computation. We want to be able to download 100 stories and pre-compute what they're going to look like and get them all ready to go off the main thread so that on the main thread we're doing almost no work. So components, I will say, is basically the ideas of React, which is a web framework open sourced by Facebook, stolen and applied to iOS native code. And we're very shameless about admitting that we just took those ideas and applied them. The idea is that you write a pure function, that is a function that takes some inputs, doesn't modify those inputs, doesn't modify any singletons or shared state. It just takes those inputs and then returns some output. That's how you think of your component. This means that they can be created and sized and laid out in any thread, right? Because they're not mutating anything. They're just taking in some value and returning a new value. So the rendering pipeline looks like this. You have one of those story immutable models that comes in. You as the developer write this first arrow here, this first green arrow that takes in that model and then returns a tree of components. So you have a story component, which has a header and a message, and the header might have a profile picture component and a name component. There you go, done. Then, that's all you have to worry about. We, the infrastructure, a different team at Facebook, the one I work on, take that component tree and actually turn it into the UI views. This means if you're writing a newsfeed story on iOS, you never have to worry about what UI views to use and doing layout subviews and size that fits. All you need to do is give us a sensible component hierarchy. We will turn it into the actual views for you. And notice that all the arrows on that slide were pointing in one direction, right? There was no, oh, I need to register for events, or I need to register for KVO on what if the name changes and update my internal state. It's all one-way data flow, and the infrastructure takes care of flowing data as things change. So remember this crazy graph with 16 arrows? If we have components, you don't need to worry about all of these arrows because we take care of it for you. The views, don't worry. That, again, that's in the infrastructure. We'll take care of the views for you. Don't even need to worry about that. So the data flow looks something like this, right? All one direction. And if something changes, because let's say the user likes the post, you don't talk to your parent component. You don't try to get back up the chain. Instead, you just flow an update all the way up to the top. You say, hey, the user liked the post. And then the infrastructure takes care of building an entirely new tree of components by rerunning your one function that you defined, and then updating all the existing views to reflect the state of this new component tree. Kind of trippy at first. It sounds really wasteful too, but it works great. Layout and sizing. If you're an iOS developer in the audience, you've probably written layout subviews like 1,000 times. I have, and I'm sick of it. I'm sick of CG float y equals 0 and then y plus equals 3 as I lay out every single thing in my view. Math sucks. It's easy to get it wrong. It's confusing. It's hard to test. What if you didn't have to do math? So we looked at a lot of different options, like there's auto layout, for example, which would let you avoid math. And we settled on something called Flexbox. So CSS is a pile of really hard to understand stuff. Flexbox, though, is a part of CSS, a relatively new part of CSS, that's actually really easy to use. It lets you define your user interface as boxes, and then say, all right, I want these boxes to flex and stretch in these ways. Makes it really easy to make user interfaces in a declarative way. You don't have to write a lot of math code. So you can say, I want these boxes to be stacked on the start or the end, or I want you to put space between them. And there's a lot of other stuff too. I encourage you to check it out if you just want to learn about Flexbox. Great stuff. We also take care of all the view recycling for you. I'll step through this one really quickly because it's kind of repetitive. But the idea is that, all right, so in iOS, we have to do all that table view cell recycling. It's all done for you. You never need to worry about hiding and showing views and reconfiguring them. The infrastructure says, oh, I have a card image. I can recycle that. I have an image. I can recycle that. Oh, a label. I can use that too. And I just need to change its text. Oh, and that text box, I don't need it anymore. Instead, I need to put a video there because that's what the user wants according to their component hierarchy. So all of this adds up to immutable views. You as the developer never have to mutate your component. Components are totally immutable. And you define them using that one-way function that takes in a model and puts out a component. Here's something what it looks like. You specify it as a, for example, you'd say, hey, I want a UI image view. And I want you to set the image using this selector and set it to this image. And I want you to call set content mode and set it to this content mode. The beauty is that behind the scenes, components knows when it recycles a view what the old values were. So it doesn't call set content mode over and over if it hasn't changed. Only when it actually changes does it rerun that selector. It's also immutable. So instead of all this junk, which is actually what the old user tap to like method kind of looked like, we have this, which is a lot simpler. Hey, top level mutator, apply, like user liked the post. I'm done. I don't need to worry about anything. Components will go along and we'll get a new model from that consistency manager with the new state. Components will rerun that function, get a new component tree, and update the state of the like button for you, including doing all that layout. No more set needs layout either. Isn't that nice? We made a somewhat unusual choice in that we use Objective-C++. You can actually mix C++ and Objective-C if you're really crazy and dangerous. This gives us type safety, which is a really nice one, right? No more NS arrays with random who knows what inside. Instead, it's a standard vector with brackets saying what types there are inside of it. We get const safety. You can actually say, hey, this you can't modify this. It's const. And a lot of nice efficiency wins in C++. We don't have to allocate objects all over the place just to act as little wrappers. And we also get aggregate initialization, which is this crazy syntax here, where you can have a struct and then initialize it being like .flex equals yes, .spacing before equals 10. It's like named parameters, which are my favorite part of Objective-C, but on steroids because you can omit the parameters you don't want to worry about. So putting it all together, we did also rewrite newsfeed later so that the UI layer was on this immutable system. What did that get us? First, again, a better programming model, right? We no longer had to worry about race conditions and mutability. Second, it took 70% less code to write newsfeed. If you're not writing layout subviews with all this math in it, you can focus on just the bare essentials, which is really exciting for us. And finally, it was performant out of the box. If you make that layout algorithm a little bit more efficient, now every single part of the code base that uses components is more efficient, which is a lot better than, okay, let me go optimize the like button, and it's only going to make the like button faster. To revisit, this is what the newsfeed story component looks like. Here's an example of a button component, right? You specify all the different images for every state. You specify whether it should be selected or not based on the model that was passed into you. The theme of all this was, don't make me do it, right? If you're a developer at Facebook, we don't want you to have to worry about configuring views and view recycling and writing a whole bunch of math. Instead, do the hard work for me. If you specify, hey, I want the view hierarchy to look like this, we'll do it for you. If you say, hey, I want you to stack these things vertically, we'll do the math. If you want to update how your story looks, it'll all be taken care of for you. You don't have to worry about getting the view and modifying the view. And finally, declarative above imperative. It makes code so much easier to read if you can just say, oh, look, it declaratively specifies that a newsfeed story is a vertically stacked list, rather than having 200 lines of code that does a whole bunch of math to lay out stuff in a vertical list. So what's the future of this components framework? The answer is we're not sure yet, because a new exciting thing came on the horizon, that is Swift. Swift has a lot of the reasons why we used Objective-C++, why we use the C++ part there, are now offered for us in Swift. Swift has generics, a lot better dealing with mutability and stuff like that. So we're really excited for Swift. So we don't know what we're going to do yet, but we'll see as it comes along. All right, so that's my talk. Thanks so much for having me, everyone here at MCE. It's been a real pleasure talking to you. And if you have any questions, let me know. Yes.
Great talk, thank you. I might have missed something, but you said that you abandoned core data and you are actually serializing objects to disk, to flash, as a plist. So you serialize all my Facebook data, like all these objects, to a single plist.
No, each product has its own plist. So Newsfeed has a plist, okay, and then Timeline has a plist, and so on.
Okay, and a single plist. So it's like you serialize like the root object, and it okay. And
that means a lot of repetitiveness, right? Like we might encode the same data in different plists, but that's fine. Like that's denormalization. We're fine with it.
Okay, and yeah, this one I'm sure I missed. So how do you synchronize changes between plists? You might have said that. But
yes. So that's a good question. The answer is we have that consistency manager. And the consistency manager has its own plist. Actually, it uses SQLite, but whatever. It has its own data storage on disk. And whatever it has is the source of truth. So if you read out one of those plists on disk, maybe that plist is from like 2 weeks ago and has a lot of out-of-date info. But as long as you go say to the consistency manager, hey, I want you to give me the new latest values for anything in this object that I read from disk, it'll update you.
Okay, so the plists are like caches.
They're like caches, yes.
Okay, thank you.
Yep.
How do you deal with the schema changes that are happening, for example, on the server side? Do you, if a model changes on the server, do you do a separate release, or is it more a dynamic thing?
So that's a great question. The question was, how do we deal with schema changes? So we've put a lot of thought into this, and actually we're just starting to talk about how we do APIs. It's really exciting. If you go watch the talk from ReactConf on what we're calling GraphQL, or how we do, like, I think they're calling it D-Lite. It's from the React Native conference that they recently had. You'll get a little feel for how we do the philosophy of models. But the answer is we don't deprecate models. We never change names or delete models. Once it's in the API, it's always there. It might no longer give you data, but the type is still there. So we don't have to deprecate old versions of the app. We still have versions of the app running on iOS 3 that work. So
let's say if a story gains additional attributes, do you create a story 2 model, or do you just add the attributes?
You can add new attributes to existing models. You just can't delete attributes. Like you can't suddenly say, oh, I don't know anything about story.message, that doesn't exist anymore. You can add story.improved message or whatever and add new information on it. Makes sense.
Can I? I'm here. Hey, one question. You mentioned that when you load this immutable model, you load also all the relationships. So how do you handle really like deep object graphs?
That's a great question. How do we deal with really deep object graphs? When you load an immutable model from the server or from disk, you specify something called a field set, which specifies, all right, so for each field, how much data do I want? And you can only go a finite depth, right? You can say, all right, I want the story and its sub-story and the stories, sub-stories, sub-stories. But there's no way for us to specify, hey, I want all the sub-stories recursively. If there are a million, give me a million. And that's just a design choice we've made. It might not work for every app, right? A lot of apps do have these kind of cycles, and they're much less common in Facebook. So it's a luxury we have, I guess.
Okay, thank you.
Any other questions?
Now using Objective-C++, do you find that there are any trade-offs, like when someone new is getting into the team and confronted with C++, or is it kind of easy adaptation?
You know, I was really afraid of exactly that, oh boy, we have all these, we have over 100 developers. A lot of them aren't familiar with C++ at all. And no, it's actually been surprisingly good. And the answer is that, like any company out there, we only use a small subset of C++'s power. And we try to limit your exposure to it, because if you see a blizzard of C++ coming at you, you're going to be like, nope, don't want any part of that. So for the most part, the only C++ you're writing is open brace, list of things, close brace, done. And then for as far as you're concerned, you don't even know what that is. So it's been fine.
Do you have any other questions for Adam? Okay, you can always get him later. So thank you very much again.
Thank you.